In this video, you will learn how to identify congruent figures and identify corresponding parts of congruent figures. Congruent figures are figures that have the same shape and same size. When two figures are congruent, you can move them so that one fits exactly onto the other one using transformations. And the three ways to make such a move, like we just learned about, are a slide, a flip, or a turn. So whether we have that we are sliding, as we do in this diagram, like a translation, flipping, as we do here, like a reflection, or turning, like a rotation, we can use one of these transformations to create the other figure. Congruent polygons are polygons that have all congruent corresponding sides, meaning that all their sides and all their angles are congruent in their matching parts. The matching vertices are what we refer to as corresponding vertices. And when you name congruent polygons, you always list the vertices in the same order by their corresponding parts. In the example that we have here, we have our two figures. The vertex at X corresponds with the vertex at Y, Q corresponds to B, A corresponds to P, and C corresponds to R. Now we can use this to identify corresponding parts. So, for example, we could say that C corresponds to R because they're both in that same position in the figure. You also could say that angle B is congruent to angle Q because based on looking at the diagram, these vertices are congruent. That means that these angles are congruent. You also could say that side AX corresponds to side PY, so they'd be congruent because they're corresponding. And then if we want to name our congruent figures, the figures match up so that A corresponds to P, C corresponds to R, B corresponds to Q, and Y corresponds to X. But notice that they're in that corresponding relationship, so they match up perfectly. In this example, we have triangle ABC is congruent to triangle QTJ, and we need to list all the corresponding parts. So if it is not already given to us, the first thing we need to do is draw a picture. Now, from the congruent statement, saying that triangle ABC is congruent to triangle QTJ, the first thing we can do is identify corresponding parts. So since A is in the first spot and Q is in the first spot, this means that these two are corresponding parts. So A corresponds with Q. Then we also have that since B is in the second spot and T is in the second spot, that T corresponds with B. So I can identify that on my figure. And finally, since C is in the last spot and J is in the last spot, those two correspond. So C and J are corresponding parts. Now, if we need to list the congruent angles, we can use the corresponding parts. So, for example, since A and Q correspond, these angles would be congruent. So you could say angle A is congruent to angle Q. Additionally, we could also say that angle B is congruent to angle T. So we could write down that angle B is congruent to angle T. And finally, since C and J correspond, you could say that angle C is congruent to angle J. Now we can do the same thing for the sides. So if I'm listing my sides that are congruent, I could say that AB is congruent to QT. So, and if we want to list it using our colors, A and Q, so AB is congruent to QT. You also could say that since B and C correspond to one another and T and J correspond, that BC is congruent to TJ. And finally, for our last side, we could say that AC is congruent to QJ, which using our notation, we have CA is congruent to JQ. In this example, it says the triangle WYS is congruent to triangle MKV, and you need to list the corresponding congruent parts. So the first thing is, if we want, since we are not given the picture, we should draw the picture. So I'm going to draw triangle WYS and triangle MKB. Now, using our corresponding parts, W corresponds to M. So that means that since W and M correspond, that those angles are congruent. So I could say that angle W is congruent to angle M. Additionally, we also know that Y corresponds to K. So Y and K would be congruent. So I could say angle Y is congruent to angle K, which I can show on my diagram and mark my congruent angles. And lastly, we also know that S corresponds with V. So I could say that, show that S corresponds to V and mark my congruent angles. So angle S is congruent to angle V. Now, this question is a little bit different in that it specifically says use 3 letters to name each angle. So when we are doing this, if we want to use 3 letters, we're just going to rename each angle using the appropriate 3 letters. So for my example, if I want to have angle W is congruent to angle M, we could either use one of 2 options. You could say that something like angle YWS is congruent to angle KMV. Again, making sure that we keep the W and the M in the middle because those are the corresponding parts. That may vary as long as you name it properly. For the other one, for angle Y, we could call angle WYS and angle MKV. Again, making sure that we keep the Y and the K in the middle since that's our vertex. And for the last one, I could say that angle S, I could call it angle YSW is congruent to angle KVM, making sure that we keep the S and the V in the center. Again, this we may not always need to do, but in terms of some situations, depending upon the diagram, we need to be familiar with naming angles in this way. In terms of the sides, everything is going to stay the same as the last time. So I could say that WY is congruent to MK. So if I'm using my color coding, W corresponds with M, and Y corresponds with K. We also could say that YS corresponds to KV, so I have Y and K correspond, and S and V correspond, so they're congruent. And lastly, SW corresponds to VM. So using my notation, I have S corresponds to V, and W corresponds to M. And again, we need to have all 6 of these parts to list all the corresponding parts. For the next example, it says triangle XYZ is congruent to triangle KLM. Angle M is congruent, the measure of angle Y is 67, and the measure of angle M is 48. Find the measure of angle X. Now, using this, we would have to first draw a picture. So I have angle XYZ and triangle KLM. Now, using what we have, we can find our corresponding parts that are congruent. So, given that the statement says that XYZ is congruent to KLM, based on the markings or the order, I could say that we're just focusing on the angles for this example, but X and K correspond, so they're congruent. I have that Y and L correspond, so those angles are congruent. And I also would have that Z and M correspond, so those angles are congruent. Now, the remainder of the problem says that the measure of angle Y is 67, so this angle is 67, and the measure of angle M is 48. And it's asking for the measure of angle X. So I'm going to call this X. Now, based on this, we have 2 triangles. However, since we have that this angle is 48 and angle M and angle Z are 48, I could say that angle Z is also 48. And now we have a triangle, and all the angles of a triangle should always add to 180. So the measure of angle X plus 67 plus 48 should equal 180. So the measure of angle X would come out to equal 65 as our final answer. So by applying corresponding parts of congruent figures, we can determine what the relationship is for the angle measures. For congruent triangles, we have a number of different things. 2 triangles are congruent when they have 3 pairs of sides and 3 pairs of angles that are congruent. Now, based on this information, we need to check because we need to see, are all the sides congruent? So you're checking two things. Are all sides congruent? And are all angles congruent? Now, based off of what we have here, all the sides, we have this side is 3, this side is 3. We have a pair of sides that are congruent. The 3's are congruent, and the 4's are congruent. So yes, all the sides are congruent. We also have, one angle that's congruent, the right angles that are congruent, and I also have that I could say that angle BCA is congruent to angle ECD by vertical angles theorem. So yes, all the angles are congruent. So we could say that our answer is yes, all corresponding sides and angles are congruent. And then for your congruent statement, we have to carefully make sure that we are labeling things so that they match up. So if I decide to call this first triangle ABC is congruent to, we would then have to make sure that all the vertices matched up for the second part. So for example, A would correspond to E, so it would be triangle E. B is next, and B would correspond to D, so B or E, D, and then finally C corresponds to itself, so it stays as C. And again, this may vary on a situational basis.